this video, I'm going to go over the project and how to research LiDAR. And so previous videos I've shown the directory structures and I have templates, and so I was given a few AOIs, and so I created in my projects regions the AOI, and then I copied those folders over that are in the template folders copy over, because I know I'm going to be writing to these folders, or some of them. So the source data was given to me, it's right here, and saved in the source, so I know the source is always here. And I'll go ahead and open up one of these into ARC. So I'm going to open up the source data. And this is the final AOI that I need to supply back to the customer, clip to this AOI. So one of the first things that I do when I receive the AOI is and you put this in a file geodatabase or whatever, but I'll first check to make sure that the data frame is right. That's right. We do everything in NAT83 and then the native zone, so that all looks right. And so I'm just going to export this out into the Delaware Shore, and I like to keep it in the GIS, and you can make it as a shapefile, file geodatabase, whatever, but I keep it as a shape, and I just call this whatever that is, Delaware Shore AOI nav, zone 17 nav 83 meters. I save it there. And another thing that I do, I have those templates. So I have a spreadsheet, and this is how I keep track of things. So in my main folder here, I've got a finals where I'm going to deliver any final data. I've already delivered 5 meter data for Fort Bragg. I just organize it region, and then I have a duplicate of, Fort Bragg was done. I have a duplicate of the directories. And then the source, when I get all my, typically put them in there. And then the spreadsheet, the main spreadsheet where I inventory things, I always keep like a main inventory spreadsheet. And those are those examples that are in that folder. But so for this particular project, I have the example worksheet already filled out. So I know that this is in, this says zone 18. But I thought the shapefile said 17. Okay, I'm going to rename that real quick. Okay, so I renamed that to make it right. I wrote down the wrong name, zone 17. So we know this is in zone 17. It's a native zone, I'm sure of it, but that's the zone that they want to deliver back regardless. So zone 18, and then I'll fill this out later as I find it. And then the DSM square kilometers, there's not an attribute already, you can calculate that. So there isn't, so we can just calculate the square kilometers just by adding a field. And I do double, and then we'll calculate the geometry in square kilometers. That's how everything is priced. So this is not a big area at all. It's only 22 square kilometers. So go ahead and put that in here. That's what I'm billing them for. But there's no more, so because this would take some time to do. Otherwise, this would be a $22 project. So this is the minimum order is going to be $450 even for this 22 square kilometer area. So I'm going to, the next thing that I do, so I document this into a spreadsheet. This helps me keep, as I'm working on these different ones, like this is the one I'm working on now. So usually I'll highlight that in yellow, the ones that I'm working on, so I know where I'm at, because sometimes I've got a lot of these, like 20 of these areas that I'm working on once. So to keep track of which one I'm working on, I'll just highlight it. So I have that, I'll figure out what that is. And then of course when I deliver things, that'll be the delivery date. Layer bounds I can get here shortly, and I'll show you how to get that. And then we'll find where the source is at a later point of the video. So the next thing that I want to do though is I usually do a 100-meter buffer from the areas that are given to me, unless it's just research. If I'm just doing pure research, like I'll get 100 areas I need to research, I don't buffer those out 100 meters. I only buffer out 100 meters on the orders. But since I know this is going to be an order too, I just buffer this out just to make sure I pull enough LiDAR and everything, and I generate enough grid and stuff so I have a little bit of a buffer, and I'll typically do this at 100 meters. So if you search for buffer, do a buffer, if you have the buffer wizard up here, but buffer analysis, and I'll do this at 100 meters. And we'll save it as and basically I'm going to do a 100-meter buffer and save it on into the folder and name it 100-meter buffer. I like to put 100-meter buffer at the end. 100 meters, we're going to put this. And I like to call this, you know, call this AOI 100-meter buffer, something that makes sense. And this is what I'm going to be primarily pulling data as from this 100-meter buffer, just to make sure I get enough information. Again, if you're doing just a research where you're just looking to see what coverages, this isn't necessary, but because it's an order, that's why I'm doing the 100-meter buffer. So now I have the 100-meter. Now I don't charge the client for the extra buffer. I don't calculate that 100 meters and put it into this spreadsheet. I only charge them for what they give me. So now that I've got the buffer, I'm going to show you how to pull in the indexes. So you have a bookmark folder. Right here. And that's what this is. And so the first one, this is kind of the main one I always use to get the latest. If you haven't done so already, now they only make this about every 6 months, they'll update this, but I want to just show you how you get this data. So download it, download the geodatabase, and it looks like I've already done that and saved it here. So I'll just open up that latest folder here where I've saved it, so I can figure out what the LiDAR coverage is in this area. So I'll go into here and the Interagency index, and I'll go ahead and open up the National Elevation Inventory feature class. And I want to also add the data links, because they've changed the structure of this as well. And so the data links shows you where, like where to get it. So this is saying these are different IDs for like NOAA, they have different IDs, and I'll show you that. Like this 8614, that's relates to the NOAA FTP site. So those are kind of important. So this is important to have the data links tied to this national elevation inventory. So as a join or and I'm going to join the table. So it's the UUID data links from the National Elevation Inventory feature class. And now I have this join. So this will give me the project name, and this is for the entire US. So now I have this index joined, I'm going to go ahead and select by location. Anything that intersects the National Elevation Inventory intersects the 100 along with the 100-meter buffer, so I can see what intersects, and I'm going to export out this data set. And I'm going to put it into the folder here and call it Delaware Shore. I like to call this one Interagency Index. Then I'm going to remove this. And then if you notice here under the project name, this is where I'm going to get the year, because that's how it's pretty useful if you could split this out by year. But I already know that some of these I'm not even going to use. I think this is just 2014, 2017. But just to show you, I add a year field here. And then if you do a left of that project name, and then 4 characters, that will get you the year. And so you could, query this. This is helpful if you have a lot of areas. This is kind of important to know the year, like to separate out the files. Just manage them better. So I'm just going to delete these, but these are the results. So it looks like it's available. There's different places you can get this from, the national map and the NOAA digital coast. Right here's, this is where we can see the link. And I'm not sure if all these are accurate. Let me look at I need to look at the structure here. So we definitely want this 2017 data here. So let's see where this is at. I'm not sure what this is. I don't want to do this on the video. I'm trying to find right here, 6329. This is it right here. So on the 2017, I want to download the NOAA data, and under this data viewer, I see that their ID is 6329, and those bookmarks that I gave you. If you go to the direct download site for the NOAA, you search for that 6329, that's the ID here. And so here's the program right here, the USAC. So I want this shapefile. This is going to be the actual index to the 2017 data. So I'll download that, and we'll put it in the proper folder. You can put it in here. Actually, what I do for this sometimes, maybe I'll include this in the folders to copy, is it from NOAA, and I'll call this when I extract it, I'll delete the Okay, so here is the index for 2017. If I pull that in, I'm going to save these edits. For now, I want to look at this 2017 coverage, which I saved in the from NOAA. Okay, so this mess, I think this is just water right here. I'm not sure what's coming out here. There's no land out here. This should cover all of Delaware. See, there's a Delaware Shore State Park right here. So this is all the coverage for 2017. Oops, go back. So for the 17 tiles, so now what I want to do is I want to do a selection by this so we can save the 2017 index. So I'll just do a select by attribute, or I'm sorry, select by location. The 2017, that index we pulled from NOAA, and it was right here because I looked up that 6329 number. This is the program, was able to get that index. One thing to notice too, I'm just doing this to show you how I grab data from NOAA, but anything pre-2020, the NOAA indexes are actually all in the folder with the LiDAR indexes. So this 2020, the NOAA coverages should be in there. So you could actually use this particular file geodatabase. Now that I know that the only thing available based off of that interagency index, which is right here, I know 2014, 2017 is, so that's what I'm focusing on now, is to grab the actual indexes. So I've selected the 2017 results, anywhere it intersected this 100-meter buffer. I'm going to export this data out, and I usually put this in here under shapes, GIS shapes, LiDAR indexes. And I'll call this one 2017 NOAA LiDAR index. And so you could repeat that for the other one in the interagency index. Again, I'm just showing you in case you have NOAA results that are in my that are not in my 2020 United States LiDAR index database. I know these entries are, but again, you would come over to here for the 2014, and should be this one right here, 4969. They have a lot of duplicate entries. I don't understand this, but what I'm looking for on NOAA's site is this where ID, not this import item, this number here from NOAA. I'm looking for this one where this 4-digit number here. So if I search for 4969, on the LiDAR site, see, I could download, this is the program right here, and I could download the shapefile. One thing though that we want to look for too is if this has break lines while we download it. So if I go back, I want to go back and look at that other area. (6329). I want to see if they have break lines, because on the NOAA site, I want to show you where you can get the break lines. If you go to the HTTP, here's the meta info, but usually they'll put the break lines right here. And I don't see any break lines for this project, which means we won't have break lines. This is the FTP access. So this is the only data set. So there isn't any break lines for the 2017 data. But for the 2014 data, take a look. look here. $4969. So if I downloaded this file, this will be for 2014. I'm going to see if there's break lines. I don't see the break lines. And I'm wondering if we should go ahead and pull this from the USGS site to see if we can get break lines. So, no break line. I can't find break lines from these two on NOAA's site. They may not exist. But if I wanted the 2014 data, for example, I would do that same thing how I got the 2017 data. But I actually have this index in here. And that's this 2020 United States LiDAR, and then I have anything NOAA 2016 to 2020. So if I load both of these in, see, I'll have all the what we're looking at here. Let's see, you can see my LiDAR index here. I don't need the 2017. So what I would do here to get the 2014 index is, if I were going to use the entire index, I would just do this. I'd do a selection, select by location, the NOAA LiDAR index. The only problem is I have 2017 and 2000, and this is 2016 and beyond. I don't have a compiled one, full merged one. So I could do a query on whatever it intersects, because well, I could do them separately, but I've already pulled the 2000 data out, so we'll see where the 2014 is. So this is another way I can get it, is through this index here. And I could do a query by whatever, but for this purposes, I think I'm going to go back and just download it from this site. 2014. I want this tile index. From NOAA, we'll call it tile index. Show it in the folder. Same thing, select by location. This time I'm going to choose the 2014, and that's why I do a 100-meter buffer, just to make sure we get enough tiles pulled down. So since this is a small area, I'm not going to bother like figuring out, because in theory I don't, well actually I don't need these. I won't need these right here because they're going to be covered. Actually I'll need this one. Probably be safe to keep this tile, but definitely shouldn't need these tiles. So I'm going to edit some of these so I don't download stuff I don't need. Although since this area is so small, I probably should just download everything. So I have the 2014 and the 2017. So I think because this area is only 22 square kilometers, I'm going to download both sets. And in the next video, I'll show you how to do that.